This tutorial will demonstrate how to compare percents and averages between two groups. In XLDA Analyst, the comparison menu is here, and we'll be discussing the comparing of two group averages and two group percent. In statistical, the statistical name of these tests is independent samples t-test. An example of independent samples t-test is when we want to compare a variable, for example, between males and females. Let's say I'm looking in this variable here called I'm worried about global warming, and I would like to see if males and females worry or not in a different ways about global warming. To compare the worryings about between males and females, I go to compare two group averages. Two group averages because I'm worried about global warming is a synthetic variable and can be treated as metric. Our grouping variable is gender, which tells the software that we would like to compare something between males and females. And the variable which we would like to compare is I'm worried about global warming. When we click OK, we see that the significance level is above 0.05, which means we cannot reject the null hypothesis, which is that both males and females have equal preferences. Actually, the software provides this answer that the preferences of males and females are equal, and indeed there are about 6.1 each. So in this particular case, there is no difference between how males and females worry about global warming. Another variation of the independent samples t-test is when we compare two group percents. For example, we may want to compare if the proportion of retired males to the proportion of retired females, and see if they are the same or not. And retired females, being retired is part of job category. Actually, it is the latest from job category. And if you would like to compare if the proportion of retired males is larger or not to the proportion of retired females, then we should use two group percents. Two group percents has no equivalent test in SPSS. SPSS doesn't care much about proportions, but this software has this variation of the independent samples t-test. So to compare it, we select gender, which means we would like to compare something between males and females, and for job category we select retired. So with this selection we'll compare the proportion of retired males to the proportion of retired females. When we click OK, again the significance level is above 0.97, which indicates that we cannot reject the null hypothesis for those two proportions being equal, and indeed from a statistical perspective the proportion of retired males is equal to the proportion of retired females. Now in the last two examples we compared, incidentally we ended up with cases where there is no difference. So I would like to demonstrate one case where there is a difference. So if I would like to compare the probabilities of males and females to purchase the largest size of a car in our data set, it's going to be gender male-female as our grouping variable, and then the probability of buying a standard size electric auto within 3 years. So now I'm going to compare this probability to buy a standard size electric auto within 3 years between males and females, and in this case the result, we have a significance level below 0.05, which indicates that the probability for males and females is the probabilities for males and females are different, and indeed the females are more likely, significantly more likely to purchase that car than males.